everyone, my name is Camille J.C. Sosa. So for today's video, I'm going to have a tutorial video about chapters 8, which is tackling about subnetting. So if you're interested in this video, please keep on watching. So subnetting. Subnetting is the strategy used to partition of a single physical network into more than one smaller logical subnetworks or subnets. An IP address includes network segment and a host segment. Subnets are designed by accepting bits from IP addresses host part and using these bits to assign a number of smaller subnetwork inside original network. Subnetting allows an organization to add subnetworks without the need to acquire a new network number via the internet service provider. Subnetting helps to reduce the network traffic and conceals network complexity. Subnetting is essential when a single network number has to allocated over numerous segments of a local area network LAN. Subnets were initially designed for solving the shortage of IP addresses over the internet. Class A and Class B and Class C include the subnet mask known as the default subnet mask. The subnet mask is intended for determining the type of number of IP addresses default. Dividing the network into number of subnets provides the following benefits. Reduces the network traffic by reducing the volume of broadcasts have to surpass the constraint in a local area network. For example, the maximum number of permitted hosts enables users access a work network from their homes. There is no need to open complete network. When two or more switches are connected together, the size of the broadcast domain is increased, and so it's the number of collision domains. The number of broadcast domains is increased only when the routers are added. Two reasons for creating subnets includes reduction of overall network traffic and improvements of network performance. The subnets also allow an administrator to implement subnet-based security policies. The number of routers or switches are not affected. Subnets do not simplify network design. Each network that is directly connected to an interface on a router requires its own subnet. The formula 2n, where n is the number of bits borrowed, is used to calculate the available number of subnets when borrowing specific numbers of bits. DHCP is generally the preferred method of assigning IP addresses to hosts on large network because it reduces the burden on network support staff and virtually eliminates entry errors. However, DHCP itself does not discriminate between authorized and unauthorized devices and will assign configuration parameters to all the requesting device. DHCP servers are usually configured subnet range so there no guarantee that devices get what. A company uses addresses block of 128.107.0.0-16. For each network, the subnet mask will provide the maximum number of equal size subnets while providing enough host addresses for each subnet in the exhibit. The largest subnet in the topology has 100 hosts, so it's at least 7 host bits. 27 minus 2 equals 126. 225 equals 0.0 has to meet requirement providing the maximum. If a network device has a mask of /28, how many IP addresses are available for hosts on this network? A /28 mask is same as 255.240. This lists 4 host bits. With the 4 host bits, 16 IP addresses are possible, but 1 addresses represent the subnet number and 1 address represents the broadcast address. 14 addresses can then be used to assign to network devices. A network administrator wants to have the same network mask for all networks at a particular small site. The site has the following networks and number of devices, IP phones, 22 addresses, PC, 20 addresses needed, printers, 2 addresses needed, scanners, 2 addresses needed. The network administrators had deemed that 192.168.10.0-/24 is to be the network used in this site, which single subnet mask make the most efficient use of the available addresses to use for the 4 subnetworks. If the same mask is to be used, then the network with the most hosts must examine for the number of hosts, which in this case is 22 hosts. Thus 5 host bits are needed. The /27 or 255.255.2.24 subnet mask will be appropriate to use for this network. Refer to this picture given the network address of 192.168.5.0 and the subnet mask of 255.255.2.224. How many total host addresses are in use in the assigned subnet? The network IP address 192.168.5.0 with the subnet mask of 255 provides 30 unusable IP addresses for each subnet. A network administrator is variably subnetting a network. The smallest subnet has mask of 255.255.2.248. How many unusable host addresses will this subnet provide? The mask 255.255.248 is equivalent to the 29 prefix. This leaves 3 bits per host, providing a total of 6 usable IP addresses. 23 minus 8 minus 2 equals 6. So, that's all for chapters 8. I hope you enjoy watching and stay tuned to my next video. Bye!